right, so let's jump right back into our next example of polynomial long division. Now that you've seen a first initial example, remember in the first topic we had a question, a division question that we already knew the answer to because we had done out the related multiplication problem, and then we were just trying to prove it, that it actually worked when we divided, that we got the answer we expected. In this case, I'm now starting out with a completely random fourth degree polynomial being divided by a first degree polynomial, x plus 2. I have no idea what the solution is, and that's actually true. I totally just made this up. Chances are it's probably not going to go into the x plus 2 is probably not going to go into our fourth degree polynomial evenly. And that's okay. It's going to yield a remainder of some kind, and we're going to talk about what to do with that remainder. So let's give it a try. Let's use our same rules from last time, which this time I'm actually going to write out for us. So the first thing that we do is we look at the leading terms of each expression, so x and 3x to the fourth. And we compare them and try to figure out which number, which we're going to write right up here, or which expression I should say, when we multiply times x will give us 3x to the fourth. So we're comparing them. We're trying to figure out the missing number in this multiplication, which in this case should be 3x cubed. And if you're not sure why, we will multiply it out to prove it. So we take this guess, we're saying I think that x goes into 3x to the fourth, I think it goes in 3x cubed times. Let's test it out. So step number 2 is to test it by distributing our number to what we would call the divisor, right? So this is the dividend and this is the divisor, if you remember our old 3rd and 4th grade vocabulary terms. So we are going to, how should I write that? We'll multiply the divisor. Distribute to the divisor, which is x plus 2. So 3x cubed times x is indeed 3x to the fourth. So that's already a good sign because we want these two numbers to cancel. And then 3x cubed times 2, because we're distributing it to each term, is 6x cubed. And I write that here, plus 6x cubed. In order to see what we have left over, we need to subtract. Or in this case, because we need to subtract every term, we'll say, let's switch the signs. In other words, we're going to subtract, just like in our typical division problem, but remember we're subtracting this term and we're subtracting this term as well. That's why we switch the signs. So we're subtracting 3x to the fourth, we're subtracting 6x cubed. Now we compare, we combine the columns. I guess I should say that. So we switch the signs and then we combine the columns. Oh, that should just be one L. I always want to put 2 L's in columns. Why? I don't know. It's like the word I always want to spell incorrectly. There we go. Now that's crazy. That's all right. We combine the first column and we get a 0, so we don't need to write that. We just say that these cancel. And then we combine the second column, 5x cubed and negative 6x cubed, and we get negative x cubed as the only remaining value. Okay, so we're done with our first division loop, or like cycle if you want to think of it, although the last thing we need to do is we need to bring down the next value, the next expression, which in this case is negative 2x squared, and then we repeat. So we go through those 5 steps and then we repeat and go back to 1, which is to take x, the leading terms, and negative x cubed and compare them and figure out what value we need to write up here. I'm going to say we need a negative x squared. Let's multiply and distribute to see if we're right. Negative x squared times x is negative x cubed. So that's good. But we have to distribute it to both. Negative x squared times 2 is negative 2x x squared, which actually in this case eliminates both columns, right? Or actually, no, yes, that's true, because I need to switch the sign, sorry. Like, wait, I forgot a step. Change that to plus, change that to plus, they eliminate, and they eliminate. Doesn't always happen, but in this case, it does. That's okay, that means it leaves us with 0. And we bring down the next value. Repeat the cycle. Now, if you're worried about this, like, what are we going to do with the 0? Don't worry, we will find a way to work with that. Start back, to the leading terms, and we say, how many times does x go into 0? Well, the answer is 0, which is just going to give us 0 times x is 0, and 0 times 2 is 0. So I'll get 0 plus 0, which is really just going to give us an x remaining, which is fine, because now we can bring down our final plus 5. Oops, I need to zoom out again here. There we go. How many times now does x go, we're repeating again, back up to 1. How many times does x go into x? Well, the answer is just plus 1, right? Because 1 times x is x. And then we distribute 1 times 2 is 2. We subtract, or we switch the signs so that we can see that the first column combines. The second column is going to leave us with a remainder of positive 3. Positive 5 and negative 2 is remainder 3. So again, we went through this cycle 4 times, right? 1, 2, 3, 4 times until we had nothing remaining, at least of this initial polynomial. And that will give us a quotient, a solution to our division problem of 3x cubed minus x squared plus 0, technically, although we don't really care about that. The 0 doesn't mean anything, plus 1. And that is our solution, except that we have a remainder of 3, which we can write just like we used to when we were in elementary school, a little r with a 3 saying there are 3 left over. Or we can write it as a fraction. Remember in elementary school, if we had, let me use a different color so I can include this all on the same page here. If I had 43 and I divide it by 3, I'd say, oh, okay, well 3 goes into 4 once. Multiply it through 4 minus 3, that's just 1. Bring down. 3 goes into 13 4 times. That gives us 12, but oh, we have 1 as a remainder. There were 2 ways we could write that as an answer. We could say 14 remainder 1, or you also learned that you could write it as a fraction. If you remember, you'd say, well, there's a remainder of 1, and we were dividing it into thirds because we were dividing by 3. So the answer could be 14 remainder 1 or 14 and 1 third. We wrote it like that. The 1 comes from the remaining number. The 3 comes from the fact that we're dividing 43 into thirds, and so we get 1/3 as our remainder. We can actually do the same thing here. We can either write it as remainder 3, or we can say plus a fraction of 3 over x plus 2. That's our fraction. So either one. This is one way to write a remainder, and this is the other way to write a remainder. And we'll practice more in class so that you can get used to this, but I want you to at least have that in your notes. So the solution to our problem is, if I take 3x to the 4th plus 5x cubed minus 2x squared plus x plus 5 and divide it by x plus 2, I get a solution of 3x cubed minus x squared plus 1, because this doesn't really matter, plus a fraction of 3 over x plus 2, or more simply, just remainder 3. And there are different times where either one of those will be a valuable way of writing our solution. Okay, that is it for your homework for this weekend, and we will talk more about this and practice more with this when we get back to class on Monday.